A single modern SUV can weigh over 2.5 tons. Now imagine hundreds of them stacked above your head. Concrete slabs, steel bars hidden inside, tires pressing down with thousands of pounds of force, engines still ticking with heat. And yet, when you walk into a parking garage, the ceiling feels low, tight, almost pressing down on you. Why? Why don't parking garages have tall, open ceilings like shopping malls? Why do some vehicles scrape roof racks? Why do trucks sometimes get stuck? And why does that striped clearance bar hang slightly lower than the actual ceiling? Today, we're breaking down one simple question. Why do parking garages have low ceilings? The answer isn't laziness, it's physics, it's weight, and it's cost. A parking garage is not just a roof over cars. It's a stack of heavy concrete floors, and each floor holds dozens, sometimes hundreds of vehicles. Let's say an average car weighs 2 tons. If 100 cars park on one level, that's 200 tons pressing down. Now multiply that by 5 or 6 levels. All that weight has to travel downward from slab to beam to column to foundation and finally into the ground. If the ceilings were taller, the columns holding everything up would also be taller, and tall columns bend more easily. That's the first key idea. Most people think low ceilings are just about saving space. That's only part of it. The deeper reason is structural strength. A short column is stronger than a tall column made of the same material. Why? Because taller columns are more likely to buckle under heavy load. Imagine pushing down on a short, thick stick. It stays straight. Now imagine pushing down on a long, thin pole. It bends sideways. That sideways bending is dangerous in structures, so engineers keep floor heights tight. Shorter columns equals stronger support. Less bending equals safer building. Lower ceilings make the entire structure more stable without adding extra material.
Here's something most people don't realize. Concrete bends, not dramatically, but slightly. When dozens of heavy cars park on a slab, the concrete sags a little between beams. This is called deflection. If ceilings were taller, the beams would have to span longer distances. Longer spans mean more bending. More bending means thicker slabs. Thicker slabs mean more weight, and more weight means even stronger columns and foundations are needed. It becomes a chain reaction. So engineers limit floor-to-floor height to control how much everything bends. Everything pushes straight down, efficient, controlled. Now let's talk about ramps. Ramps inside parking garages can't be too steep. Most are limited to around 15 to 20% slope. If each floor were taller, the ramp would need to stretch longer to reach the next level. Longer ramps take up space, and space inside a parking garage equals parking spots. Parking spots equal revenue. So keeping ceilings lower shortens the ramp length. Shorter ramps mean more usable space. This isn't just engineering, it's economics. Construction cost is often calculated by volume. If you increase each level's height by just 1 foot in a 5-story garage, that's 5 extra vertical feet of structure. That means more concrete, more steel reinforcement, longer columns, more exterior wall material, more ventilation volume, more fireproofing. It adds up quickly. 1 extra foot across a large structure can add enormous cost. So engineers design just enough clearance for typical vehicles. Most passenger cars are under 6 feet tall. Typical garage clearance, around 6 feet 8 inches to 7 feet. Just enough room, not wasted space.
Imagine a 10-story parking garage built with 12-foot ceilings. The columns would be much taller. To prevent buckling, they would need to be thicker. Thicker columns take up parking space. Heavier structure means deeper foundations. Deeper foundations mean more excavation and higher cost. And now the building weighs significantly more, pushing harder into the soil below. Suddenly, those extra few feet of air create massive structural and financial consequences. Parking garages have low ceilings because shorter columns are stronger, shorter spans reduce bending, lower heights shorten ramps, less volume saves huge construction cost, and tighter structures better control movement. It's not poor design, it's optimized engineering. Engineers don't build extra air, they build exactly what's needed to hold thousands of tons safely, and nothing more. And the next time you duck slightly under a garage ceiling, you'll know you're standing beneath a carefully balanced system where even a single extra foot would change the entire structure. If you enjoy simple things explained through real engineering, stick around. There's a lot more hiding in plain sight.